everybody. Pleasure to be here. Thank you for coming on a Saturday, on a weekend. So, as said, my name is Chen. I'm the EY America's blockchain leader. What that basically means is that I work with organizations in order to develop blockchain technology and identify and develop blockchain use cases, implement them in the industry. And what we're going to do today is mainly discuss where EY sees blockchain go in the next few years, and we will give a few examples of projects that we have running in production or close to going live in production, so you will get a sense of what kind of directions we are seeing in the market, and then we will also, if you would like, try to answer some questions. So let's start with this. You don't see the slide so much, but why is blockchain linked so tightly to what's called the industrial revolution 4.0? So, I need to do it like this. So, first of all, blockchain isn't alone, and blockchain alone would be great, but the big thing about the industrial revolution is that blockchain is coming together with many other technologies that are all maturing at the same time. Let me move this better. So many technologies that are maturing at the same time. When we say at the same time, is a range of 10 to 15 years. And you know, I said every time I show this slide, when I prepared this slide, I ran out of room in the slide way before I ran out of technologies that are mature. There's so many technologies, so many changes, all happening at the same time, and all together, and the combination between them, if we talk about blockchain, our ability to connect blockchain to IoT, to big data analytics, to robotic process automation, all together bring a situation where our ability to change and influence business processes is very big. There's a nice exercise I like to show, like a nice graph that I like to show at these kind of discussions in order to prove that this change is not something new and we should learn from history. So this graph shows a major technological breakthrough in the last 200 years or so, and the time it took a quarter of the American population to adopt the change. So we see two distinct trends. The first trend is that the time it takes to adopt the change is dropping exponentially, and the second thing is that the distance between lines is getting closer and closer. This graph ends in the 1990s. If I go back for a second, and if I would continue and try to put all these technologies on this graph, I would just get a big bulk here of change. And this is what drives this technological revolution. You know, you can do a nice exercise in your mind in order to prove that 10 years from now, the world is not going to look the same. This already happened. Let's look from 2019 to the year 2000. Our lives were already completely changed in the last 20 years. So 20 years ago, I was at least already deep in my adult life. We didn't have smartphones. How could we manage without smartphones? No WhatsApp, no Gmail, no Uber, no Get, no Google Maps. Our lives have already completely changed, and there's no reason to think that in the next 10 years they will not change again. So think about that when we think, you know, when there's a debate, is blockchain and are all these technologies going to change the world in the next 10 years? Yes, of course they are. So let's talk about blockchain. We'll start by discussing the EY vision, then we'll do some use cases in action where we see that, and then we will discuss where to go from here. So when EY approaches blockchain, we mainly look at the business-to-business scenarios, and we ask ourselves, where do we see blockchain influence business scenarios? We see two distinct axes where this is really bringing value. The first axis is where we have simultaneous transactions with many parties. So in any business ecosystem, where we have many parties influencing the ecosystem, influencing the supply chain. So again, supply chain track and trace across multiple parties. Food traceability, where you have a food producer, and then you have carriers, and then you have supermarkets, etc., many parties. We see distinct use cases for blockchain technology. The other axis is where there's a lot of complex business logic, again, usually between multiple parties. So in a complex procure-to-pay, order-to-cash ecosystem scenario, where the order-to-cash is between many parties, definitely a good use case. When you have complex intercompany scenarios, again, we see definite advantages of blockchain technology. We'll give examples later. And the most sexy or beneficial use cases is where these two axes meet. So, for example, in the area of intellectual property licensing and funds distribution, in the area of fund supply chains, insurance, some cases of obviously financial services with complex agreements, this is where we see high benefit and very good use cases for blockchain technology. The second part or another reason why this is so beneficial is that ERP systems in any of these scenarios simply fail. So let's take intercompany, for example. As long as I have a single instance ERP across my entire organization, the ERP does a great job at solving intercompany. But once we break the ERP into several instances, intercompany is a mess. Same thing with traceability of supply chain. As long as it's in one ERP, great, no problem, excellent job. Once we break it to several ERPs, then our supply chain goes across several entities. Very, very difficult to perform, and this is exactly where we see blockchain bring tremendous value to the ecosystem. By the way, I didn't say so, but if you have any questions, raise your hands. I'll try to answer as we go. If it takes too much time, we will give it to the end, but we'll be happy to take also questions as we go. So how EY sees, or where EY sees blockchains go from here? We see, and I'll explain this further in the next few slides, we see two things happening that will enable a revolution. One is fiat currency, mainly dollars, being tokenized. Dollars as an example, okay, any currency. So the problem with cryptocurrency is that they are not stable, they are very, very volatile. But blockchain is good at managing currencies, any currency. So we see fiat currency, dollars, euros, yens, whatever being tokenized, and we also see assets being tokenized. And once both assets and fiat currency will be tokenized, we see smart contracts managing the exchange of fiat currency from customer to supplier and ownership tokens over assets from supplier to customer. This is what blockchains will do in the next few years. In other words, it means that the same way as ERP took processes in an organization, master data in an organization, and reports in an organization, and created a single way of working, a single version of the truth for the single organization, blockchain has the ability to create the same single version of truth for entire ecosystems. So in other words, we will see in I'll add another level to that. In order for this to happen, we don't believe that the solution is many, many small ecosystems that will interoperate between them. The only way for this to work, same way as we work today with the internet, is to have a single blockchain that is public, that is allowing private transactions to happen on it. Same way as today we use VPN in order to transact over the internet. So we see a single blockchain evolve, probably out of Ethereum because it's the largest and has the most traction and the most chance to become this internet of value. And we see this public Ethereum or whatever it will evolve to become the infrastructure. 1 second, let me finish the sentence. So we see public Ethereum become, or public blockchain become this infrastructure on which organizations transact privately and securely, moving asset tokens from one side to the other and fiat currency tokens the other way. Question?
What does it mean to tokenize an asset? This building is here. What does it mean to tokenize it?
We will talk about it in a second. Okay? I will answer. The question was, what does it mean to tokenize an asset? So, you know what? We can do it now. Where's my phone? Phone? I need a phone. Thank you. So, that's it. This is an Apple, right? So, the idea of tokenizing an asset is as follows. When I am Apple, as I finish producing this phone, I also create a digital token that represents the ownership over this phone. Why is this important? Why it's important to represent the ownership over the phone digitally? Because blockchains enable us, and also from Otto's lecture earlier, Otto showed how blockchains are very good at handling and managing money, meaning managing that there's no double spend of value. In the easiest use case is money, right? When I take $100 out of my pocket and give it to you, you know for sure that I didn't get to keep it because I cannot replicate or duplicate $100. The same way the technology makes sure that a digital $100 are not replicated. But the same thing can happen with assets like phones. So when I tokenize the phone, and I now start to move it across the supply chain, there's no way to introduce a counterfeit phone into the system because it behaves exactly like money. Introducing a counterfeit phone or a counterfeit phone token would be like counterfeit money. In this case, almost impossible. And I get two things out of it. When I buy the phone and I expect to get not just the physical phone, but also a digital token representing the ownership, it means that if the seller does not have the token, holds the token as well, it means the phone is either stolen or forged. So we basically get a situation in which we make it much harder to introduce fake goods into the ecosystem. And you would think this would go to phones and to expensive stuff, but actually where we see this go is into food. There's a lot of food counterfeit, and a lot of food that is, we don't know the source, we don't know what it was sprayed with, we don't know how it was kept. One second. And blockchain's ability to make sure that once we tokenize, we know what we are buying, and we know the source and not just the source, but the entire supply chain that the goods that we are buying went into, makes it a perfect candidate for things like food, tokenizing food, and tokenizing medicine. So I hope this answers the question. Yes. Yeah. Yes.
I'm gonna tell it again. You tokenize the phone, but you tokenize this building. I'm the owner of the building, I have the token of the building. Let's say somehow someone stole you the token of the building. I'm the owner of the building, but someone else have the token of the building. What happened in that situation?
So what you are describing is the same thing as someone entering the government records, right, and changing in the government records who owns the building. You will have the same problem exactly. Okay, so only I think changing records in a thank you, much better. Let's just focus. So what you're saying is true, but it exists also today. So if someone, let's take a easier example than building a car. Okay, so I have I'm registered in the DMV as the owner of the car, and I have the car. If someone enters the DMV records and manipulates the data, so he is shown as the owner of the car, you have exactly the same problem today. This is much more secure than the DMV records like policy. Right, so, or the registers of the government. So, and this is decentralized. So, the fact that that today we have a piece of paper showing ownership, and tomorrow it will be a digital token showing ownership, is not such a big difference. The only difference is, or the big difference is that in order to now sell your house or sell your car, you need to go to the government and ask them, please can you change the records? In the future with blockchain, you can do it peer-to-peer. You simply receive digital money, and in return, you give your token to someone else. More than that, today, fractional ownership, meaning to split the ownership of this building between many parties is quite complex. With tokens, very easy. Right? So this technology will have a lot of advantages in that sense. Let's see if this works. Let's talk about another advantage of why to tokenize phones, why to tokenize assets. So one capability that we developed within EY and actually even patented, but I'm pretty sure that others are doing things that are similar, is that we have developed the ability to nest tokens. Nest tokens means put one token inside another token. So when we look at a supply chain scenario like this, and when we go back to the phone example, the phone starts with raw materials or assembly parts. Let's say the phone has a screen, it has a plastic case, and it has a motherboard. So all of these would become, let's see if this is also a laser. Yes, maybe. So all of these are tokens representing the parts of the phone. And when I assemble the phone, it's not that. Now how will it go back? Yes. Sorry. So all these parts go in, all these tokens that represent spare parts go into a token that represents the phone. As the phone is packed and moved along the supply chain, the tokens can first of all go into boxes and crates, and we move the crates along the supply chain. And when it reaches the end seller, it goes back to individual phones. And when someone buys the phone, then he gets ownership tokens over the phone. He knows the entire history. That when I buy an Apple phone, I know for a fact only Apple produced the phone, no one else. But it doesn't stop there. Phone screens break. It's inevitable. It's only a question of when, not if, right? The screen will break at some point. When this happens, and I go to a store to fix the phone, there is no way for me to know that the repair shop is using original materials. the guy tells me it's original materials, the guy shows me that package, maybe that with the original materials, there's no way for me to know for sure. With this, when he replaces the token that represents the screen with a new token produced by Apple, I know for sure this is an original piece. So also support and maintenance in this scenario are much, much better than what we have today. Let me take it one step further. We said, and I'll go further by going back. Not that far, I'm going back. Wait, I need to move closer. We said that blockchains can manage tokens the same way that they manage money. Same thing goes with the inventory. So, unlike the scenario today, when inventory moves between ERP systems, it gets, when an ERP system ships inventory, it basically puts it in a kind of bucket, for example, inventory in transit, and this inventory disappears. And when the other ERP receives it, the inventory reappears in the inventory records. Blockchains that treat inventory the same way as they treat money. There's no way for inventory to disappear and reappear like it happens today. Meaning, if I shipped 100 pieces and I put it on a truck, and the truck represents an e-wallet, for example, when the other side receives the goods, first of all, he cannot receive more than 100 tokens, right? Where did the extra tokens come from? And second of all, let's say that I received 90, not 100, then the 10 tokens don't disappear, the 10 tokens stay on the truck. I know where they are. Meaning I can manage, again, a single version of the truth across an entire supply chain. Let's talk about use cases. Where do we see this in action? So I'll start with a use case. I'll just go back to the original keyboard. So, sorry for the quality of the projector, it's a bit weak, better. But anyway, one use case where we see this live in action is with the Microsoft Xbox. Here we have an ecosystem of many players with a complex business logic. Let's take an example. My favorite example is the FIFA football game. So FIFA football game on Xbox costs, I'm sure, how much does it cost? Not the EY guys that we had this yesterday. How much does a FIFA game cost on Xbox? $60, thank you, right? This is the price, always. So this $60 are divided by many parties in the ecosystem. EA Sports gets a piece, FIFA gets a piece, Microsoft gets a piece, Ronaldo's pictures on the cover gets a piece, everybody gets a piece. Today, this mechanism of reconciliation between all the parties is very cumbersome. Microsoft takes the sales data, does the calculation, sends it to all the parties needs to agree and send back their approval, and then the money is sent. It takes 90 days to reconcile each month. What we've done with blockchain is, again, as we said earlier, complex business logic, multiple parties. We took the contract that says who gets what out of every dollar, and we simply put it on a smart contract. We connected this smart contract to Microsoft's sales system. So now the smart contract knows almost real time what were the sales of the FIFA game each day. And assuming that all the parties got to check that the smart contract is exactly the same as the legal contract that they signed, they automatically agree to the result. And we took 90 days of reconciliation to 0. This is working in production. Part parties like EA Sports now have complete visibility, almost online. We call it same time, not real time, but same time as Microsoft. They see the sales data, they automatically agree to their part of income without needing to reconcile and calculate, they believe, the smart contract. The change here is not just by the reduction of effort that happened because they don't need to reconcile. The change here, the bigger change here is the amount of trust that came into the system, meaning there is no disputes anymore. As long as they agree that Microsoft is not manipulating their own source system, they agree to the result. And second, and more important, the level of visibility that they get to the sales information, instead of seeing it weeks later, they see it almost online. So, amazing use case that completely changes this industry. And now when you think of it again, complex business logic, many parties. The amount of use cases the same thing has in high-tech, in telecommunication, in media and entertainment, in oil and gas, in mining, anywhere where you have a situation where rights and royalties are an issue between multi-parties, the same logic applies. Questions or let's take another example. Again, an example that is already live in production. An Italian wine manufacturer suffers heavily millions of dollars of loss every year from counterfeit wine that is presumed, has the same label as their wine. What they do is tokenize the wine across the supply chain, and me as a consumer, in Italy, when I get to buy the wine, I just scan the label has a QR code, and I get the entire history of the wine bottle from the winery up to my hand. And then I always get the question, okay, no big deal, so the counterfeiters will simply copy the QR code and continue to counterfeit the wine. Well, no. And I'll remind you why. We already said that if we tokenize the goods, there is no way this is fully reconciled the same way money is reconciled. There is no way to introduce fake tokens into the system. If I mark the bottle as consumed, then when someone else comes and scans the same QR code, he will get a result that this bottle has already been consumed, has already been bought. We see this going into several directions, the same technology, food traceability. We see it go into cheese, into more, of course, more wine manufacturer. We see it go into frozen food that is being counterfeit. We see it go in very much a similar way into vaccinations and into pharmaceuticals that also suffer from counterfeit. So we have many use cases where food traceability is a big thing. One other big example, this one is on a hyperledger, by the way, is lettuce. We have Walmart, I don't know if you know, but the US had a big scare with lettuce problems. Walmart is going to track and trace lettuce across the supply chain, preventing counterfeit lettuce or problematic lettuce from coming in, or if problematic lettuce is identified, since I have complete track and trace, instead of calling off the entire lettuce from the US market, I can call off specific batches, something that they don't have the ability to do today. Another example for the same track and trace capability, we see in logistic companies. Schneider is a big logistic a provider that uses a lot of third-party logistics. The problem with third-party logistics is that they don't use the same ERP system. They use many, many systems in order each to manage their own warehouse, which basically means that Schneider does not have end-to-end visibility over their supply chain. By connecting all the different warehouse management systems and all the different ERP systems into one blockchain that receives all the data, and I'm not saying this is easy to do, there's a lot of master data issues, it's not simple. But once you do it, Schneider gets, and this is work in process, Schneider gets full end-to-end visibility over its supply chain. Again, no goods can disappear or reappear. And this is very strong. Inventory starts behaving like money. The value is tremendous. Another interesting example that we see with a product that is called Tesseract. This product enables the fractional ownership over assets and the fractional usage of assets. What does that mean? So the first use case is in Australia, where every farmer has a tractor, because every farmer needs a tractor. But when we talk about a combine or a harvester, because Australia is so big, the crop does not mature at the same time. So a harvester could sit, I don't know, 9 months out of the year doing nothing, and the farmer would only use it for 3 months, but these 3 months are not the same 3 months across all of Australia. So we've got a lot of harvesters sitting doing nothing just because they are needed for a short period of time. What we are doing is enabling shared ownership over harvesters with tokens, and shared a usage of harvesters the same way. Picture the UI of Uber, it looks very similar. So a farmer just logs in and books the harvester when he needs to, and of course he pays according to usage, and this payment is split between the owners according to the ownership over the harvester. And we get a much more efficient ecosystem instead of every farmer or every group of, every local farmer owning a harvester. This already works, and the use cases here are much, much larger, of course. Think about cars. Think about self-driving cars. When there's a self-driving car, I don't need to own a car. Someone else can own a car, even a few people can share ownership over a car, and I just use an Uber-like UI in order to use cars. Cars will come, I will get in, I will go out, I will pay, very similar to Uber, only a blockchain can manage the entire process with full transparency and move the value from my pocket as a user to the owner's pocket automatically. So we definitely see a lot of potential to this kind of technology in the next few years. Question? Yes?
These use cases work UI
Yes, all these use cases. So EY is kind of strange in this area. Thank you for the question, important question. In this area, EY behaves like a software company. Actually, one of the leading blockchain software companies in the world. We have around 150 developers worldwide. These developers are developing use cases, developing the infrastructure, and also developing capabilities to make public blockchains feasible. One example we will talk about maybe later is the usage of what we mean with zero knowledge proof. That will be mandatory for, at least the way we see it, that will be mandatory for public blockchains to mature. So all of these are real use cases that are already live. Yes?
So I have not so much a question, but a
statement.
A statement, a comment, just something that's very difficult to understand when you first get into this world. You did mention it, but I just wanted to re-emphasize it a bit.
Sorry.
Oh, Siri wants to talk as well.
Only a matter of time before she needs the existence.
No, but once you tokenize something for one particular use case, it's now tokenized, and you can now use it for many other kinds of use cases. So you may tokenize something for supply chain management. Amazing example, by the way, really interesting what you're doing there. And now you've tokenized these products, and now you can use it as part of your finance, you can use it part of trade finance, credit, a bunch of other kinds of application. And it's really exciting once you have this on the blockchain and it's tokenized. There's so many other applications that you'll all of a sudden find.
Yes. So literally these things are gonna shape the future in the next few years to come. I don't know where I left my phone, so time, just time. Okay, so we have 10 minutes, that's perfect. Okay. So let's do a few other use cases and discuss where all of this is going. So another use case that comes from a completely different angle is transparency of government. So we have several use cases. One is in the municipality of Vienna. We have another example also in Canada, where budgets and legal documents are all put on a blockchain for the citizens to simply see. So think about, let's take the Canadian example. I think it's a bit more advanced than this. The Canadians take their budget and put it on the blockchain and tokenize it, the dollars. So any usage of the dollars is recorded on the blockchain. There's no way to cheat since this is tokenized. Again, behaving exactly like money. And citizens get full transparency into what their taxpayer dollars, or dollars in Canada, right, are being used. Think about a world where you as a citizen see where your dollar taxes go to. I think places where I come from, like Israel, it's going to take like another 100 years to reach the situation. In places like Canada, it's already a reality. So, very interesting use case as well. Let's see what else we have. I think this is the last one. Yes. So what's next? In order for all this amazing vision to become a reality, a few things need to happen that are not there just yet. The first thing that needs to happen, we need to move from private to public blockchains. Right now, public blockchains are not secure enough. They are too transparent, meaning, what do I mean by too transparent? I mean that if I am a business organization and I start putting my transactions over a public blockchain, my competitors can see what I'm doing. This, of course, is unacceptable. So right now what we are doing all these things on private blockchains. We are doing it on private blockchains that will later easily be migrated to public blockchains, meaning we are using infrastructure like private Ethereum and Corum because they are highly compatible with the public Ethereum. We would not use other private blockchains that would later be an issue to migrate into the public blockchain. The other thing that we are doing in order to make it a reality is heavily investing in the development of zero-knowledge proof. Zero-knowledge proof would simply, and for lack of time, I would not go deep into it, but simply would mean that I would be able to move tokens across the public blockchain without revealing what I am moving, but still keeping the consensus mechanism whole and proving to the system that I did not double spend, that I did not copy-paste digital value. We have already been successful in moving tokens over the public Ethereum without revealing to the network what we move, just confirming to the network with a complex mathematical calculation that we did not double spend. So whatever we moved from, we took out on one side is what came out on the other side. This is already reality, working. We are constantly working on improving this because these complex calculations right now are too complex to become a high volume. But we have already, I think, in the last 3 months dropped the calculation needed, the calculation time needed by 85% or so. And this is still work in process. The other thing that needs to happen today, a lot of the blockchain work that is being done is notarizing documents, meaning using the blockchain in order to sign documents and prove that they are authentic. This is nice, but this is not enough in order to make the vision a reality. In order to make this vision a reality, we need to tokenize assets. And today, most of the projects that we take upon ourselves, if there's no tokenization involved, we would usually not do it. Notarization is not enough in order to make the vision a reality. Next thing that needs to happen is the move from crypto to fiat currency, meaning we need to start transacting with dollars, euros, yens over the blockchain, not bitcoins, ether, etc. And from all of these, the third column, is the closest to reality. We will see, and there's a lot of cameras here, so you can record me. We will see digital dollars over the blockchain, over Ethereum, still in 2019. We already have it with Gemini and a few other small startups. But we will see dollars being put on the blockchain by large institutional banks in 2019. This would be a reality by the end of the year, hopefully even closer. When this happens, and when we have a large bank saying whenever you come to me with a digital dollar, with a dollar token, I will give you regular dollars back, we will see many, many more legitimate organizations move forward with the adoption of this technology. Because to quote prices with Bitcoin is not realistic. To quote prices with dollars, we do all the time. So we will definitely see this happen. Last but not least, from separated to integrated, mainly means that we need legislation and regulation to support all of this move. We need regulators to understand that this technology is here and that they need to change and adapt the laws and regulation in order to support this technology. It will only make things better. It will reduce the black market economy. It will make everybody pay taxes. It will make tax payment automatic in many ways. There's lots of incentives for governments to go into this direction. And we are working heavily with the US regulator, spending more and more time in Washington in order to educate and make this a reality as well. Of course, this will take a few years to come. So I think I have like 5 minutes left, and we can open for questions.
Thank you. I have 2 questions. The first one is with the integration. You said that the implementation that we see, they are separate right now. So in order to have this, to be adopted and to grow up, so you need to have those integrations between different implementations. What would you think would be the biggest challenge in that matter in order to make sure that that's going to happen? So more people is going to be interested in adopting this. This is my first question. The second question is that you talk about that you can have tokenized assets and you can have one person holding that asset, that token, but also it can be that you say that it can be that, for example, a car can be owned by different people. So in that case, what would you say that would be the implementation? It would be something like having Bitcoin and Satoshis. Can you have something like that with the contracts?
So let's answer the second question because it's easier to answer. Tokens can be partially owned. Okay, I can own 30% of a token. I can also split tokens. So, for example, a building like this, I would not create one token, I would create a square foot token. And I would split, that a square foot is of course not a specific square foot. But a building like this, let's say it's 10,000 square feet, I would create 10,000 square feet tokens, and this is how I would split ownership. Right? So if it's a car, I would just have either percentages or more tokens, but definitely a percentage. As for the second question, how is this adopted? So, two parts to the answer. First of all, the first part is, since we are building this technology on compatible Ethereum solutions, to adopt it into a larger internet should be easy enough. If you build your solutions on other infrastructures, could be hardware, on other blockchain platforms. The second thing, I want to be a bit more specific. In terms of adoption, first of all, what we have here is a bit easier than a B2C scenario. We don't have tens of thousands of customers. We have a limited ecosystem. So the way we approach the adoption on an ecosystem is, A, if you have a big player that can force its rule and wants. Microsoft is a perfect example. Microsoft decided they want to use blockchain technology for this. Everybody needs to adopt. Or they can drop out of Xbox. Right? So that's one way. The other way that we see is consortiums, meaning that enough players, critical mass of the ecosystem, come together and decide that they want to make this change. We see this in insurance and in some food producer scenarios. And last but not least, if we have big organizations that are big enough, we do this with an intercompany scenario. Meaning if you take, let's take just an organization that is not yet a client, Procter & Gamble or Walmart. Walmart are big enough, Procter & Gamble are big enough to create this within their own four walls. They take one decision at the top, everybody needs to adopt. And this is how we see adoption generated. Where is Otto? Tell me when to stop. Maybe when you finish it.
Maybe take like 5 more minutes for questions if you want, but
Okay.
up to you.
More questions.
Specifically, as for the Xbox example, how did you deal with transforming those tokens into real money for each party?
Perfect question, thank you. So, for now, as digital dollars are not something that is widely accepted, we stop at the issuing report stage, meaning the smart contract issues a report saying EA Sport is entitled to this, FIFA is entitled to this, etc., etc. The money itself moves in regular wires. But we have another use case with the telecommunication industry. In the telecommunication industry, they have already agreed on tokens that represent dollars. In that case, the smart contracts move the money itself. In the Xbox example, it will still take for the ecosystem to agree, or what we are building on for large banks to issue digital dollars, and then we will just move digital dollars backed up by a bank, problem solved. More questions? So, okay, Otto, have you finished? Perfect. Thank you very much for your kind.